everyone, so today's question is called binary search tree iterator. This question is a bit difficult to understand. It took me quite a while to understand how the inputs were given. So basically the question says that we have to implement BST iterator class that represents an iterator over the in-order traversal. BST iterator tree node root initializes an object of this class. The root of this BST is given as a part of constructor. The pointer should be initialized to the non-existent number smaller than any element in the binary search tree. Then we have hasNext function, which will return true or false if the tree has a right pointer or it has nodes left, then it should return true, else it will return false. Next is int next function, which will basically give us the smallest number from the tree. Over here it says move the pointer to the right, then return the number at the pointer. So this is basically trying to say return the smallest number. Okay, so you can go through the example. The example is easy to understand once the question is understood. Now, how the first question is how input will be provided. So the tree is already pre-made. We don't have to make the tree or anything. We are provided with its root value. Since we have the root value, we need to find the smallest value using the next function. Now, how can we find a smallest function? We'll move to its left and store all the nodes in stack. So let's see the example. If this is my tree, I will be starting from this pointer, that is 7, right? 7 will be my starting pointer. Now I will say that I'll continue pushing 7 and its left node in a stack. So eventually my stack will look something like this, right? 7 and 3. Okay. Now function next will be called, and function next job is to return smallest element of the tree. Now if you notice, we already have the smallest number of tree on the top of stack, right? So smallest element of the tree is leftmost element, and we already have leftmost element present in the stack, that is stack top. So we can simply return 3, we can pop 3 and return it, right? Okay, now over here also, once we pop 3, we'll pop 7, but now we won't have the next smallest element, right? So there will be two cases, that is stack top node, that is this top node is leaf node. If it's a leaf node, we can simply pop it. For example, when 3 was at the top of stack, we can simply pop it. Now stack top node is not a leaf node. In that case, if it has a right child, we'll push that right child into the push stack. Will be another function which will continue to push the elements in the stack, and it will go like something like it will push 7, then 3, and eventually it will push all the left counterparts. And if it has a left child, it's already processed. Now let's go to an example. So continuing with this example, we push 3 and 7. Okay, now if we pop 3, so 3 is a leaf node, and when it's a leaf node, we can simply pop it, no worries. And if it's 7, now 7 is at the top. Now 7 is not a leaf node. So now look at the tree and see what will be the minimum now. So if you look at the tree, the minimum element now, once 3 is gone, 7 is gone, it's 9, right? Now how will we reach 9? So we'll simply do what we did earlier, which is when our pointer was pointing at 7, we pushed 7 in the stack, and then we were able to push 3 in the stack eventually. Similarly, now we'll make a pointer point at 15, and it will push 15 in the stack, and then it will push 9 in the stack, right? Okay, so we'll do the same thing, and then to get 9 on same thing which I just said, to get 9 on top stack, we'll pass that function which was pushing in the stack to the to 15, and it will eventually bring 9 at the top of stack. Okay, so I hope that was a bit understandable. Now coming to the code, I have already written the code. We'll go one by one, line by line. So first we'll make a global stack, and it will be initialized with tree node. Now this BST iterator, we'll say that whenever we encounter BST iterator, we'll simply redirect it towards another function called stack push. Now this stack push, what it will do is, like for example in this question, it was starting from 7, so 7 will be pushed to this function, right? It will be like stack push 7 instead of root, it will be 7 here. So now stack push function, basically it will point to the tree root node, which is this. So it will point over here, it will point to 7 node, and while t is not null, it will continue pushing. It will basically travel to the left counterparts, and it will continue pushing the nodes in the stack, just like what we did over here. So now we have a stack with elements 3 and 7 in it. Okay, now this was the stack push function. Now let's come to has next function. Has next, as we discussed. So you can think, if there's no element left in the stack, that means we have traveled through entire tree, and we have gone through all of it. Now we can simply return false because stack is empty. Else return true. Now this functions in next. So as I said, there will be two cases. So if stack top is leaf node, we can simply just pop it and leave it. But if the top has a right child, then we'll have to push that right child in the stack push. Now we are again using the stack push function, which we used over here. So we'll simply say this, and since we already took the value of stack top in this top tree node pointer, we'll return its value. So this was the explanation. I hope it was understandable. You may just go through the video once if it was not understandable. Yeah, thank you so much.